Welcome back, guys. In this video, we have to determine the values for the constants m and n, where the vector a, -3m and 1, and vector b, 2, 7, and n, are collinear and perpendicular. So two separate questions. So let's start off with collinear. Well, as we know, when two vectors are collinear, what does that mean? We can get one of the vectors by just multiplying the other vector by some kind of scalar. So let's introduce this k value here. So k is a scalar. Right? So any scalar, if we multiply it by b and we're able to get a, then a and b are collinear. So what that means, let's write out the components here. So we got -3m and 1 is equal to k times vector b, which is 2, 7, and n. So -3m and 1 is equal to, let's distribute that k inside, so 2k, 7k, and then we got nk. So now we can set up equations. So basically -3 has to equal 2k, m has to equal 7k, and then 1 has to equal nk. And notice that we can find the k value from this right here. So divide both sides by 2. So k is basically -3/2. That is the scalar that relates a and b. We got it from the x components because both of them had numbers. So basically vector b times -3/2 would give us vector a. And that would make them both collinear. So now that we know that k is -3/2, we could plug it in and get the m and n values. So here, 7 times -3/2, that gives us -21/2. And then over here, we'll have 1 equals n times -3/2. Divide both sides by -3/2, or multiply both sides by the reciprocal. So we'll multiply this by -2/3. So these cancel out to 1. N is -2/3. And those are your answers for part A. M is -21/2, N is -2/3. So part A has a unique solution for both N and N. There's only one way that both of these can be collinear, and that's if M is -21/2, N is -2/3. Right, so I'm going to write those down here. So -21/2, and then we got n is equal to -2/3. Okay, what about if they're both perpendicular? Well, if they're both perpendicular, it's going to be a little bit different. If two vectors are perpendicular, then what? We know that the dot product between the two vectors is going to equal 0. So basically the dot product between vector A, -3m and 1, and vector B, 2, 7, and n, has to equal 0. So when we do that, when we multiply the components, we got -6 plus 7m plus n equals 0. And yeah, we could just leave it like this, or let's maybe just keep the variables on one side. Let's bring the -6 over, so +6. So notice in this case, there's going to be an infinite amount of solutions. So we can pick an m value of 1, let's say. So we'd have what? 7 times 1 plus n is equal to 6. What's the n value going to be? It's going to be 6 minus 7, which is -1. So that there is a possibility for both of these vectors to be perpendicular. What's another possibility? We can sub in, let's say, m equals 2. If m is equal to 2, then 7 times 2 is 14. We'll have 14 plus n is equal to 6. N is going to be 6 minus 14, which is -8. Right? That's another case. And we could just keep going for any m values. Doesn't even have to be integers. We could use decimals as well. We could put in like 1.72. for m, and then get an n value, right? So there's an infinite amount of possibilities for part B. These are two of them. So if m is 1, n is -1, then both of these vectors will be perpendicular. And you could test it. You could plug in m for, you could plug in 1 for m here. You could plug in -1 for n. Take the dot product between the two vectors, you'll get 0. Or you could plug in 2 for m, -8 for n. Dot product between them, it's going to be 0. So this here has an infinite amount of solutions, right? Part B. And here is 2 cases that work. Part A has a unique solution. There's only one solution for part A. There's only one way that these two vectors can be collinear. That's when m is -21/2, n is -2/.